Hello guys, how are you? Welcome back. We are continuing with our topic. In the previous video, we looked at work done. Now we are going to look at energy. So this will be our focus in this video. Energy is the measure of the ability to do work. Energy is measured in joules too, just like work done. Work done, in fact, is equal to energy transferred. Right? Now, we want to look at the different forms of energy. The first one here is the chemical energy. Chemical energy. So, when there is chemical energy, there is a potential of chemical reactions. Just like in fuel, right? We have petrol, right, which is burned in cars. We also have firewood, right? At home, we use firewood for making fires for cooking. So how are chemical reaction, and wherever there is chemical reaction, there is burning, right? So when you think chemical energy, you have to think of something burning, right? Then coal, another coal. Then we have food, etc. Okay, with food, for instance, you eat whatever you eat, right? So after eating, there is chemical reaction. There are chemical reactions actually taking place to release what? Energy. So that's it. These are forms of chemical energy. Then we have electrical energy. Electrical energy ke kwa e leng gore tota a go na le electrical energy teng. Ke kwa e leng gore ha o ka khoma nengena tena le electric energy wa o shuka ke motlakase. Like megala ya nenyana ke megala ya motlakase ha le gore motlakase wa hita current ya flow ha o ka khomana ka letsogo wa go shuka ke motlakase ke go supa bona go na le electrical energy. So we are saying this is found in electrical conductors flowing with current, right? Then we have heat energy. This one is a result of having one object at a higher temperature, right? When an object has a higher temperature, we say it has heat energy, right? Heat energy. So this results from a higher temperature. So when something is gaining heat energy, its temperature will be rising, right? Then we have sound energy. Sound energy is carried by a sound wave and actually detected by our ears, right? So you might have heard, actually nobody can say they've never heard a sound. You have heard a sound, you have produced a sound. When you hit on a table, sound is produced, right? And then it travels as a sound wave to the ear of maybe some other students who are nearby, and they can detect that sound with their ears. We are saying it is carried by a sound wave and detected by our ears. Then we have light energy. The fact that you are able to see something, whatever it is, that means there is light energy. If there is no light energy, there will be total darkness. And in that case, we cannot see a thing. Right? So we are saying this enables us to see around. Without it, there is total darkness. Right? Then we have nuclear energy. It is the energy that is released from the nucleus of an atom. So it is the energy released from the nucleus of an atom. When we generate electricity using nuclear plants, that's where these kind of reactions occur in a nuclear plant to release energy that we can use at home in the form of electrical energy, from nuclear energy to electrical energy. Right? Lastly, we have radiant energy. Well, this one is found in electromagnetic waves such as infrared and microwave. So anything actually at a higher temperature will radiate heat. So that's radiant energy, right? So anything at a higher temperature around you will radiate heat towards you. That's radiant heat. Okay? So these are the different forms of energy. I have written the description of the energy forms nicely so that we can clearly see, right? So now I want us to look at mechanical energy. Mechanical energy. Under mechanical energy, we have kinetic energy, gravitational potential energy, and elastic potential energy. But we are going to focus on these two in red, right? Kinetic energy. This is the energy of a body due to its movement. So it is the energy possessed by a moving object. Gravitational potential energy. This is the energy possessed by an object due to its position above the ground. So let's go on and look at examples of kinetic energy and gravitational energy. So let's start with kinetic energy, denoted Ke. So this is the formula for calculating kinetic energy. Kinetic energy Ke is equal to half mv squared. M is mass in what? In kilograms. V is the speed or velocity. Speed in meters per second. Then of course Ke is the energy in joules. So here is an example. A car of mass 2000 kg moving at a speed of 20 meters per second has 400,000 joules of kinetic energy. Let's try and calculate that. So this car is moving in this direction. Obviously it has some mass. It is moving at a particular speed. The speed is actually 20 meters per second. The mass is 20,000 kgs, right? Then Ke is equal to half mv squared. Half times m. What is m? Oh, I actually wrote 20,000 instead of 2000. So I'm going to cancel this 0, left with 3 zeros, right? Times 2000 kgs times the speed v is 20 squared, right? So what do we do? Half times 2000 times 20 squared. What is 20 squared? 20 squared is 20 times 20. 20 times 20 is 400. So if we punch our calculator, this is what we get: 400,000 joules as expected. So this is the value of kinetic energy. Remember, kinetic energy is possessed by what? By a moving object. When an object moves, it possesses kinetic energy, and the formula is half mv squared. So now let's look at the gravitational potential energy. Sometimes it's just called potential energy. Actually, for the most part, we'll call it potential energy. So here is gravitational potential energy, PE. This is the formula that we are going to be using. PE is equal to mgh, where m is the what? Mass, once again, in kgs. Then g is the strength of gravity. G is equal to 10 Newton per kg. Then we have h is the what? The height above what? Ground, or above any point as we can choose. Height in what? In meters m. Right? Good. So here is an example. An object of mass 50 kg is lifted up to a height of 3 meters above the ground. We'll have a potential energy of 1500 joules. Let's confirm that. PE is equal to mgh. M, 50 kg. 50 kg times g, the gravitational strength, is always 10, times h, height above ground. This is the height above ground, which is 3. Then this is equal to, this is 50, right? This is 500. 500 times 3 is 1500. This is in joules. This is PE, potential energy. So this is our potential energy. Now I want to emphasize something here. Let me change the colors. Well, I want us to note something here. If I increase the height, okay, initially we had 50 times 10 times 3. Instead of 3, I'm going to double this to 6. 6. So what will be the potential energy in that case? 50 times 10 is 500. 500 times 6. 500 times 6 is 3000. 3000 joules. So 3000 joules, PE will be 3000 joules. What have you noticed? If we double the height, the potential energy also doubles. So from this, we can see that when we have PE is equal to mgh, right? mgh, and I've written h with a different color to indicate that for a particular object, potential energy will always depend on what? On its height from the ground, its height. its height. So this mass, when it is maybe lifted up to midpoint, which is 1.5 meters, 1.5 meters, because we have divided 3 by 2 to get 1.5, we are also going to get half of the total potential energy. What I'm trying to say is, if you double the height, the potential also doubles. If you decrease it, potential energy also decreases. Same with kinetic energy. Kinetic energy depends on velocity for a particular object, right? For this particular car, Ke is equal to m half m v squared. So if we increase the velocity, kinetic energy also increases for the same object, right? If we decrease the speed, the kinetic energy also decreases. So I want you to know that kinetic energy for a particular object depends on its speed, and potential energy for a particular object depends on its height from the ground. Okay?